Hi, this lesson is on thermal energy or heat energy. The symbol is given by the letter E with a subscript H, like this. So here's the formula. You have E is equal to m, the mass of the object, C, called the specific heat capacity, and the change of temperature. So what exactly is this? Well, basically, it's the amount of energy required to heat up any substance. But of course, the more substance you have or the more mass you have, it will require more energy. Also, the change in temperature, if it's a greater change in temperature, it will require more energy as well. Lastly, C, the specific heat capacity, is based on the actual substance, like ice, water, metal, plastic. All those items that I suggested all have different rates of absorbing energy. So let's write this down. EH, that is the heat energy gained or lost in joules. So it's the same energy unit as the mechanical energy. M, mass of the substance, and this is measured in kilograms. I'll do temperature change first. So this here is change in temperature. And this can be measured either in degrees Celsius or Kelvin. And lastly, specific heat capacity. Specific heat capacity. All right, what is that measured in? Well, let's take a look at our units. We have energy is measured in joules. We have mass measured in kilograms. And we have temperature, which is measured, let's say, in Celsius, just to make it a little easier. I'll show you how to convert back and forth from Celsius to Kelvin in a minute. Perfect. Okay, so now looking at this unit over here needs to have joules, because if you multiply it through, you need joules for energy, and it needs to cancel out kilograms, and it needs to cancel out degrees Celsius. And that is the heat capacity units. So this is a weird looking unit, but that's okay, because it actually does make sense. Specific heat capacity is how much energy is needed to either change the temperature by 1 degree Celsius per kilogram. So for every 1 kilogram of substance, to change it by 1 degree, you need that much energy. And so that's the units for this. If you actually multiply it through, the units do work out, and you will get joules at the end. Now let's explain more about specific heat capacity. How do we get this, or how do we calculate this? Well, basically, to get these values, you actually Google them in real life, all right? And they're actually determined by experiments or experimental values. So I'll just write it right here and continue. So basically, the specific heat capacity, the values are obtained by experiments. So we'll do a couple of experiments later, hopefully, to show you how to get this value. So essentially what you need to do is Google it. So the problem sets that I've given you, you do need these values, but that's okay. You don't have to Google them, thank goodness, because what I've provided is a chart when you're doing your problem set. So here is some questions, and there's a chart right there, and it will tell you the values of this heat capacity. You'll notice that each value is different. So I take aluminum, for example. The heat capacity, again, is joules per kilogram per Kelvin or Celsius. In this case, it really doesn't matter. Oh, there's water right there. All right, you'll notice it's 4,200 joules, all right, per kilogram per Kelvin, or Celsius in this case, it doesn't matter. I will explain why in a moment, but basically it takes about 4,200 joules to increase the temperature by 1 degree for every kilogram. Whereas gold only takes 130 joules. That means it's easier and faster to heat up gold than it is water. All right, so there's different values for each substance. So here we have the values are obtained by experiment, so you have to Google it, and each substance has a different value. All right, let's explain the difference between Celsius and Kelvin. All right, I got two rulers over here, and you'll notice the pink one on the left has units of centimeters. All right, now how do I know this? Well, here I have another ruler, the clear one on the right, and I'm going to use the black one because the bottom's in inches. It does say centimeters right here, okay? And we're just going to line them up to make sure that these two rulers are pretty much measuring the same unit. And they are, so they're pretty much lined up all the way down like so. Okay, so you got a centimeter ruler, which is pink, and a centimeter ruler, which is clear. Well, the Celsius and Kelvin is similar. They have the same size unit. Okay, so the unit is the same, and I'll just draw the unit over here. Same size unit. Okay, so the same size unit for both. The only difference between Kelvin and Celsius is that Kelvin starts 0 way down below. So I'm going to shift this ruler up, and the Celsius starts further up. Now, what do I mean by shifting? Well, basically, the Kelvin scale, 0 degrees Kelvin, or 0 Kelvin, I should say, 0 Kelvin, is equivalent to negative 273 degrees Celsius. That's called absolute zero. That's the coldest you can ever have. All right, so that's called absolute zero. You can't get any colder than that. And that's where the scale of Kelvin starts. Whereas for Celsius, well, where is 0? Well, we all know that 0 starts at freezing or melting of water. And so it's shifted higher up in a sense. So for 0 degrees Celsius, that's equivalent to boiling, or not boiling, freezing or melting. So freezing of water, I should say freezing of water or melting of ice. That's where 0 starts for the Celsius. So you can have negative values and positive values for Celsius, whereas Kelvin is always going to be positive values because they start at 0 at the very coldest temperature possible. All right, and that's the difference. Now, because they're the same size, you can actually interchange them. So we don't have to really worry about the units. The only time you actually have to worry about the units is for mixing and matching. Remember, this is change in temperature, and change in temperature is technically T2 minus T1. Both of these temperatures must be the same unit. So they both have to be Celsius or they both have to be Kelvin. You cannot mix and match. All right, and so both of these are either Celsius or both of these are Kelvin, all right? And so you cannot mix and match. Do not mix and match. You have to make sure that there are the same units because it sort of makes sense. If I want to subtract 0, do I mean 0 when ice is freezing or do I mean 0 when it's like the lowest temperature possible? All right, and so that's why you have to remain consistent. All right, let's try an example. Okay, so we'll have our first example over here. And the question is, how much energy is required to heat 1 kilogram of sand from 20 degrees Celsius to 32 degrees Celsius? All right, so the formula we have here that we're going to use is E is equal to mc delta T. So we have 2 kilograms of sand. We need the specific heat capacity of sand, so this is where we go to our chart and we look up sand, which is 800. Okay, so 800. And then we have the temperature. Since these are both Celsius, we don't have to worry about converting. So here you go, that'll be 32 minus 20. All right, keep in mind, delta T is equal to T2 minus T1. So T2 is your final temperature first minus the initial temperature. All right. And then you work it out, and it hopefully, according to your calculator, you typed it in, it will be 19,200 joules. Let's do one more example. All right, how much energy is required to cool a cup of water from 25 Celsius to 10 degrees Celsius? All right, first of all, we've got to figure out how much is a cup of water. Well, hopefully you remember from grade 9, the density of water. Density of water. Oh dear, anybody remember? That will be 1 gram per milliliter, or you can do 1 kilogram per liter. Essentially, it's the same thing. All right, so how much is a cup? Well, this is using, kitchen, measurements. We're going to assume that 1 cup is equal to 250 milliliters. Okay, so therefore, if you have 1 cup of water and you know the density, well, remember, density is equal to mass over volume. If you can't remember that, that's okay. Just look at the units over here. It says kilograms over volume, or liters. All right, so that's the density. And if it's 1 here, then it's going to be equal. So therefore, 1 cup of water will always be 250 grams. Okay, so let's answer the question. Here you have E is equal to mc delta T, and we need to figure out how much energy you need to cool the cup. So you need to take away from the water. Okay, so we have mass, but remember, mass has to be in kilograms. So don't forget to convert 0.250 kilograms. The density, or not the density, the heat capacity of water, we're going to look that up in the chart, is right there, 4,200. And then we have the temperature. So the temperature is going to be 10 because that's T2 minus T1, which is going to be 25. All right. You will notice once you calculate it out, you're going to get a minus 15,750 joules. All right. The minus sign is given because this is being cooled. So therefore, you have to lose energy. Loss of heat energy. So you have to actually lose that energy to cool the water down. All right. Why don't you guys try some of these questions? All right. You will find them in the next handout. So you have all the specific heat capacities that you need. And here are some questions. The next lesson will be about heat exchange. Have fun. See you later.